My name is Marcin Niemyjski. I'm a junior data scientist at Cloudflare, and today I would like to talk to you about why the popularity is at least a big problem when it comes to serving data through WMS. So let's start. So maybe let's try to define problem before solving it. When I was working on our EO for UA initiative, which aims to serve the spatial data related to Ukraine through WebGIS platform, I realized that the OpenStreetMap base map, WMS, which I was using, works better at specific hours, and more precisely, it works better when everyone is asleep at the middle of the night. And yeah, it helped me to define two problems: that WMS is not capable of managing big load of huge load of requests, and it struggle when it is a big traffic on reading the source data. So I tried to take this use case and recreate it using the possibilities created by my company. So I took the satellite imagery, I took the EO data repository, which is over 35 petabytes of data on S3 storage with set backend. It's over 10,000 of disks, and it solves the problem of reading the data. At least when it comes to the satellite imagery stored on the efficient storage with set backend. The second problem, the huge load of requests, is solved by deploying Mapserver on Kubernetes cluster with defined autoscaling. So how does it look on the Kubernetes side? The happy user sends a request which hits the Kubernetes cluster, and more precisely it hits load balancer. From load balancer, request is redirected to one of the nodes. And what's important, the number of nodes depends on the number of GET requests hitting the cluster. We define it using the GDAL, scaled object definition, and Prometheus metrics. So, and from there, from the node, there is only one code per node to maximize the effectiveness of Mapserver. And from there, the request goes to the set matrix and hits the source data, which is COG or JPEG 2000, which is not so cloud optimized, but about this in a moment. And how does it look on the Mapserver side? So Mapserver is using a super cool tool called TileIndex, which is the spatial index for raster layers. It's a footprint vector storing the path to file and its metadata like polarization for Sentinel 1 or cloud cover for Sentinel 2. Also timestamp is possible to use. And we are using the virtual storage infrastructure by GDAL to hit the S3. And from the S3 we are using the COG files or JPEG 2000, which is, like I said, not cloud optimized, but offers the variety of options when it comes to spatial resolution. And within the map file, which is a configuration file for Mapserver, we are able to create the pyramid from it. So the data for 10 meters resolution is only requested for really high zoom levels. And yeah, I ran some tests. I did run some tests using the JMeter load tool. And as you can see, the throughput increases with time. The cluster is scaling, and even though the throughput is so big, the average response time remains stable and even decreases. And here is, unfortunately, it is a little bit blurry, but you have to believe me that this is the screenshot of horizontal pod autoscaler definition from Kubernetes. and thank you.